All right, today's topic, dot diagrams. So, lithium-7 and sulfur-32. I'm right on the page, says the top, electron dot diagrams and electron configuration hotel practice, or orbital diagrams. So, I'm going to do the orbital diagram first, and then I'll show you how to do dot diagrams. So, lithium-7 tells me nothing, right, about electrons. But the atomic number of lithium is 3. Therefore, 1s2, 2s1. So when you do the electron dot diagram, or the orbital diagram, right? Distance from the nucleus, 1s, 1 orbital, up and down. Why? Those 2 electrons, one going clockwise, one going counterclockwise, and 2s with only 1. Okay? Sulfur. A little bit of a bigger one. Sulfur's atomic number, whereas this hyphen notation, its atomic number is 16. So therefore, 16 electrons. 1s2, 2s2, 2p6, 3s2, 3p, I think it's 4. 2, 4, 10, 12, 4. So now if we were to do the orbital diagram, it would look like this. 1s, 1 orbital, spherical shape, 2 electrons will fit inside of it, Hund's rule. 2s, 1 orbital, 2 electrons inside of it. Then we get to 2p. There are 3 orbitals, p of x, p of y, p of z, right? 2 electrons will fit. Well, 1, 1, 1, because they'll take their own room if they can, but unfortunately, along comes a roommate for each of them, because we got to get to 6. We're not done yet, so we end up with 3s, 2 electrons there, 1 up, 1 down, and we get to 3p, which is, there are 4 of them, p of x, p of y, p of z. Up, 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 that's 3 of them, but we got to get to 4, so you could choose any of them. I'll choose the one in the middle. I could have chosen any of them to put the 4th one. I could have chosen the x, the y, or the z. Okay, here it is. Here is dot diagrams. What we do on dot diagrams is we do this. We write the element symbol. So lithium, its symbol is Li. Now here is how this works. If we have a sample thing that is element X, you put the S's here, the P of X's here, the P of Y's here, and the P of Z's here. What does that mean? It corresponds to this. Remember, this means distance from the nucleus. So if I was to ask you, what are the valence electrons, you would say, this one has 1 valence electron, and it's right there. If you were to draw lithium, right, it would look like this. It would have 3 protons, 4 neutrons, 2 electrons, and 1 electron. So indeed, 1 valence electron. And it's right there. It's the same one. So what you do is you go find the furthest ones up and you square them. That's what I always do first. And then I count the number of electrons. There is 1. It is located in an s orbital. Therefore, they go on the left-hand side, and there's only 1. So you put 1 single dot. And that is the dot diagram of lithium. Let's do sulfur. Well, sulfur, symbol is an S. And when we go and we look at distance, you would circle all of these found at the 3rd quantum energy level. Let me prove it to you. So sulfur, right? 16 electrons. So I'm going to draw it fast, but 16 protons, 16 neutrons, right? There'd be 2, there'd be 8, there's 8, and 6 more, right? So 1, 2, 3, 4, and then 2 of them would get pairs. So choose that one and that one, right? For a total of 1, 2, 3, 4, 5, 6 valence electrons, right? Well, here we go. 1, 2, 3, 4, 5, 6. Those are the same 6 electrons, okay? This pair is these 2. This pair is these 2. And then this is the P of X, that's the P of Z. Okay? So, total, we have 6 of them. 2 of them are in the S, right? So therefore, S's go to the left right there. You have 1 P of X, so there is 1 right there. We've decided to put 2 in the P of Y, so we're there. And then the last one is a single right there. Now, could it have looked otherwise? Yes. If we would have chosen to put the double there, then our dot diagram would have looked like this. 2, 2, 1, 1. Or if we had chosen to put the double there, the second one there, it could have also looked like this. 2, 1, 1, and 2. It does not matter where you put it, as long as your dot diagram matches your orbital diagram. And that is dot diagram.